Welcome back to the Foundry by Forge College. I am absolutely pumped to jump into this with you today. We're calling this explainer our architect's blueprint. And our goal is simple, but it is incredibly important. You know, in our previous lesson, we gathered a huge amount of observational data, basically a slightly chaotic pile of fascinating insights about Cloudbreak integration and real-world deployments. Today, we're going to take that chaotic pile and totally transform it into a highly focused, perfectly reproducible research plan for your capstone project. We are officially moving from just observing to architecting.
Okay, let's dive right into this blueprint. Here's the game plan for today. We're going to cover moving from chaos to structure, check out a really cool city planning mental model, run through a strict 6-stage research workflow, build your very first district, and finally get you fully prepped for data collection.
All right, Section 1, From Chaos to Structure.
So, in our previous modules, we gathered a ton of messy, observational data about Cloudbreak. We saw how pairing Cloudbreak with RPC caching layers drops read amplification. We looked at the operational trade-offs around state sharding. And hey, that data is pure gold. But right now, it's just observational. It's a bunch of notes and cool aha moments. Which brings us to the big million-dollar question. How exactly do you take all those raw observations and turn them into a tight, reproducible technical paper? Because trust me, if you just start measuring things randomly, oh boy, you are going to wake up the terrifying, project-eating monster we all know and fear, scope creep. And we absolutely do not want scope creep eating your capstone.
The answer is actually pretty straightforward. You've got to limit your scope, and you have to firmly define what success looks like before you collect a single piece of telemetry. Establishing these strict boundaries right now, that is literally the only way to make sure we're comparing Cloudbreak architectural designs quantitatively. We need hard data here, folks. We can't just throw rhetorical arguments at the wall and, hope they stick.
Moving on to Section 2, the City Planning Mental Model. To keep all these ideas perfectly organized, we're going to lean on a super helpful core metaphor. And this brilliantly illustrates the whole thing. Instead of getting totally lost in the abstract weeds of state storage, let's just treat Cloudbreak's runtime environment exactly like an urban district. Look at how perfectly these concepts map to one another. In this mental model, Solana's accounts and state objects, those are your physical parcels of land. Cloudbreak's layout decisions, those are the zoning rules telling you what can go where. Your RPC nodes act as the streets and the transit links that move all the data around. And those research questions you're coming up with, they're the planning commissions deciding what actually needs to be evaluated. So measuring read throughput, that's just like measuring traffic flow on a busy main avenue. And checking disk I/O or account access latency, that's exactly like seeing if there's any side street parking available. It's a fantastic way to ground these really heavy technical concepts into something we can instantly, intuitively visualize.
Now, for every single research question you ask, your planning commission is going to need to do 3 specific mapping activities. First up, map the stakeholders. Basically, who actually cares about this metric? Is it the validators, the RPC operators? Second, map the flows. You need to trace exactly which subsystems are moving the data. Think back to how Turbine data handling fragments block transmission, right? And third, map the built environment. What are the existing constraints you're working with? We're talking things like account size limits or rent exception behaviors. Sticking to this 3-step mapping is what keeps your research strictly, safely bounded.
Let's move to Section 3 and see how this builds into the 6-stage research workflow.
Okay, so now that we've got our city planner hats firmly on, we need a real step-by-step workflow to get our zoning approved. Here are the 6 stages you'll use to convert those chaotic insights into a solid plan. Stage 1 is question formulation. This is where you pull out 3 to 6 key observations for inquiry. Stage 2 is metric definition. You got to define your exact units. Are we talking throughput, tail latency? Stage 3 is data source mapping. Where exactly is this data coming from? Then stage 4 is experiment design. Stage 5 is prioritization, because let's face it, your time is limited and you can't test everything at once. And finally, stage 6 is documentation mapping. This is where you map out the actual structural stubs for your final capstone paper. Boom, 6 steps to success. I want to highlight this framework right here because it is basically your holy grail for stage 3 data source mapping. Just look at how seamlessly every task maps to its required imports to generate really specific expected outputs. Let's say your task is to measure P99 latency. Well, your input is RPC logs, your method is a parallelized RPC benchmark, and your output? A clean latency distribution CSV. Or, if you want to analyze resource costs, you'd need node CPU and disk metrics to output CPU seconds per 1K reads. See, it is beautifully structured. We're totally eliminating the guesswork here.
All right, let's get practical in Section 4, building your first district.
Let's actually take that workflow and apply it to our real-world scenario. Imagine we're framing a research question around a cache-first read path combined with Cloudbreak's indexing. Our very first measurable outcome here is P99 latency. Now, if you're new to that term, just think of it like waiting in line at a grocery store. If 99 people out of 100 breeze right through the checkout in under a minute, but that 100th person is stuck waiting 10 whole minutes for a price check on some exotic limes, well, that 100th person, that's your tail latency. In our network district, we absolutely have to stress test that tail behavior. We need to know for sure that the network stays reliable, even under the absolute worst-case, highest concurrency workloads.
And to evaluate that properly, we have to set some seriously strict criteria. For example, we might say that any configuration claiming an improvement absolutely must show a statistically significant absolute reduction of at least 10 milliseconds in that P99 latency. We aren't just looking for something that feels a bit faster. No way. We are setting a hard, measurable pass or fail threshold before we even flip the switch and turn the machines on.
So the crucial point is, we apply these strict thresholds across the board. Take our second outcome, read amplification. We might demand at least a 20% decrease in the ratio of account bytes read compared to the logical bytes requested. And, this is super important, we have to stipulate that achieving this 20% decrease cannot completely blow up our CPU seconds per read budget. Because, let's be real, you can't just throw a ton of raw computing power at a problem and call it an architectural win. That's totally cheating.
Finally, we arrive at Section 5, preparing for data collection.
Okay, listen up. Before you even think about running synthetic client drivers or executing trace replays, we need to make absolutely sure your city zoning plan is approved and good to go. To do that, you've got to remember these 3 practical principles of capstone scoping. Number 1, anchor your questions to concrete observations. Number 2, specify your measurable criteria up front, just like we talked about. And number 3, reuse existing artifacts. Use the architectural diagrams and turbine traces you've already generated. And you know, as a quick aside, this kind of structured, artifact-driven approach to learning, that is exactly what we champion across all our programs here at Forge College. It is all about building on what you've already proven, rather than exhausting yourself reinventing the wheel every single time.
So, I'm going to leave you with one final, big question to think about. What is your first Cloudbreak district going to reveal once you actually start running that data? I mean, you've got your blueprint now, you know exactly what your metrics are, so it's time to gather those turbine traces, grab those RPC logs, and get yourself totally ready for the data collection phase. If you want to explore more about this topic or just dive deeper into the nuts and bolts of Web3, definitely make sure to visit us at forge.college. Keep building, keep mapping out those districts, and I will see you in the data trenches.